Let us find all the real number x comma y or all the complex number x comma y that satisfy the equation x square equal to y plus 1 and y square equal to x plus 1. So we want to solve those two equations simultaneously. From equation 1, y equal to x square minus 1. Therefore, squaring both sides, y square equal to x square minus 1 whole thing square. But from equation 2, y square equal to x plus 1. Therefore, x square minus 1 whole thing square equal to x plus 1. Now, instead of x square minus 1 can be written as x plus 1 whole thing into x minus 1, because a square minus b square equal to a plus b into a minus b. Factoring this has an advantage that you can take x plus 1 as a factor. Let's write everything to the left hand side, and we obtain x plus 1 whole thing square whole thing into x minus 1 whole thing square minus x plus 1 equal to 0. Now we take x plus 1 common and we obtain x plus 1 into x minus 1 whole thing square minus 1 equal to 0. Now we have product of two number equal to 0. X plus 1 whole thing into this equal to 0. Then we must have either x plus 1 equal to 0 or maybe both of them are 0. X plus 1 into x minus 1 whole thing square minus 1 equal to 0. If x plus 1 equal to 0, then we get x equal to minus 1. If x plus 1 into x minus 1 whole thing square minus 1 equal to 0, now we cannot take anything common, we just have to multiply it. X plus 1, a minus b whole thing square is a square minus 2ab plus b square. Once again we multiply with x plus 1 to obtain x cube minus 2x square plus x square minus 2x plus 1 minus 1 equal to 0. Now 1 minus 1 we can cancel out and we can take x common. So x into x square minus 2x square plus x square gives us minus x square, x common, so just x. X minus 2x will give us minus x, and we take x common, so minus 1 equal to 0. Therefore, once again, if product of two number is 0, then one of them has to be 0. So either x equal to 0 or x square minus x minus 1 equal to 0. Now if x square minus x minus 1 equal to 0, that's a quadratic equation of the type ax square plus bx plus c equal to 0. So roots are given by x equal to minus b plus minus root over b square minus 4ac by 2a. That's equal to minus of minus 1 is plus 1 plus minus root over b square minus 1 square is 1 minus 4 into a is 1. And then c is minus 1 divided by 2 into 1. That's equal to 1 plus minus root 5 by 2. Now the question is saying solve for x and y. But we have solved for x only. So we obtain 4 different choices of x. X equal to 0, x equal to minus 1, and x equal to 1 plus minus root 5 by 2. when x equal to 0, from equation 1, y equal to x square minus 1 equal to minus 1. When x equal to minus 1, y equal to minus 1 whole square minus 1, that's 0. When x equal to 1 plus minus root 5 by 2, y equal to 1 plus minus root 5 by 2 whole thing square minus 1, that's equal to 1 plus 5 plus minus 2 root 5 by 2 minus 1. That's 6. 6 minus 2 is 4. So 4 plus minus 2 root 5 by 2, that's equal to 2 plus minus root 5. So all the pairs x comma y are given by when x equal to 0, y equal to minus 1. So 0 comma minus 1. When x equal to minus 1, y equal to 0, minus 1 comma 0. When x equal to 1 plus root 5 by 2, y equal to 2 plus root 5. When x equal to 1 minus root 5 by 2, y equal to 2 minus root 5. One may speculate that for x equal to 0, we can write y square equal to 1, so y equal to plus minus 1. Maybe you will say we should have two different answers, x equal to 0 as well as x equal to 1. However, you observe that when x equal to 0, we obtain y equal to plus minus 1. But if you write this y equal to plus minus 1 in this equation for x equal to 0, equation 1 will not be satisfied for y equal to 1. So for x equal to 0, the only choice is y equal to minus 1. Similarly, we'll get 4 and only 4 number of solution corresponding to x comma y, 0 minus 1, minus 1 0, 1 plus root 5 by 2, comma 2 plus root 5, and lastly x equal to 1 minus root 5 by 2 and y equal to 2 minus root 5.